Welcome to today's Explainer. We're going to completely decode the Cambridge IGCSE Additional Mathematics 0666 syllabus and really master one of its most foundational topics. Look, if you've ever stared at a blank exam page and felt that sudden, sinking rush of panic, well, you are exactly in the right place. Today, we're zeroing in on the circle equation, but more importantly, we're going to look at exactly what the examiners are actually hunting for when they read your answers. Here's our exact roadmap for today. We'll start with Section 1, the circle equation core. Then, Section 2, the procedural framework. Section 3 is the method mark strategy. Section 4, top 3 examiner warnings. And finally, Section 5, critical analysis for top scorers. Let's get right into it. Okay, Section 1, the circle equation core, mastering the fundamentals. So let's dive into an area that honestly trips up even the absolute best prepared students. This quote right here from senior examiners really highlights why we need to focus so heavily on a connected, conceptual understanding today. It's incredibly common for students to get all tangled up here. And it's not because they can't do the math. It's usually because they haven't firmly grasped the underlying concept. So we are going to change that narrative entirely right now. All right, here is the absolute core equation. You must not only memorize this, but you need to be able to confidently apply it to totally unfamiliar contexts. It's x minus a all squared plus y minus b all squared equals r squared. Now, I know it looks like a bit of a mouthful, but let's just break it down simply. The a and b in there, they give you the exact coordinate point for the very center of your circle. And the r, that represents your radius. When you look at this, please don't just see a random string of letters. See a map. It's literally the geometric DNA of the circle, right there on your page. Now, here's a really crucial point. Cambridge's assessment framework distinctly prioritizes analytical depth way over just memorizing a superficial breadth of mathematical facts. So what does that actually mean for you? Well, it means just memorizing the formula we just saw isn't quite enough to get those top grades. You have to really understand how to manipulate it, how to pull evidence-based reasoning from it, and exactly how it connects to other geometric principles when you're suddenly faced with a completely unfamiliar multi-stage question. To really lock this equation into your brain, try attaching the variables to a memorable visual story method during your study sessions. It sounds a bit unusual, but it works like a charm. For example, imagine A and B as your home-based coordinates on a treasure map, and R as the exact distance you need to walk in literally any direction to find the gold. By actually visualizing the equation rather than just repeating it over and over, you build that deep, connected understanding the examiners are desperately looking for. Moving right along to Section 2, the procedural framework, executing the standardized sequence. So knowing the formula is step 1, right? But knowing how to systematically apply it, that's step 2. Systematic processing follows this exact 5-step standardized sequence to make sure you never, ever lose your place during a stressful exam. First, identify and extract the key data, like coordinates from a text block or a table. Second, apply the relevant principles, which basically means pulling out our trusty circle equation. Third, execute your analysis with absolute clarity on the page. Fourth, verify your results to catch any of those silly little errors. And fifth, present your final answer precisely how the question demands. This sequence, it's your ultimate safety net. And keep in mind, it is not just about the numbers. Your data interpretation must strictly follow these presentation conventions. The syllabus heavily emphasizes that presentation is a critical, scorable skill. If you're sloppy with your annotations or you accidentally use the wrong terminology, you are literally leaving easy points on the table. Think of your exam paper like a professional report. It needs to be incredibly logical, clean, and structurally sound. Okay, on to Section 3, the method mark strategy. Process over perfection. I cannot stress this enough. This next strategy can literally rescue your final grade. Showing your clear step-by-step working is an absolute non-negotiable rule. It actually transforms the math exam into a points-gathering game. A lot of students think mathematics is just a strict binary. It's either right or it's wrong. But Cambridge actually awards you for your process. If you follow that 5-step procedural framework we just covered and you document every single step on the page, you are actively gathering method marks the whole way down. See, the crucial takeaway here is that examiners actively want to award you marks for your process, even if a minor, silly calculation error ruins your final answer. Let's say you perfectly set up the circle equation. You substituted the correct center coordinates and the radius, but in a moment of panic, you accidentally added 2 plus 2 to get 5 at the very end. Your final answer is technically wrong, but because your working showed perfect analytical depth, the examiner can still award you the vast majority of the points through method marks. So please, never, ever skip showing your work. Let's look at Section 4 now. Top 3 examiner warnings. Decoding the principal examiner reports. Now, principal examiner reports are an absolute goldmine because they literally tell us exactly what goes wrong year after year. By knowing these 3 specific pitfalls, you can systematically verify your own work and protect your hard-earned marks. First up, students routinely forget to present their final answer in the proper circle equation format. Second, in the wild rush of the exam, they abandon all presentation conventions. We're talking messy writing and 0 clear annotations. And third, they provide really generic answers instead of interpreting the data specifically for the context given in the question. Avoid these 3 traps and you're already way ahead of the curve. Finally, Section 5, critical analysis for top scorers, reaching the evaluation level. This right here is where we separate the good students from the truly great ones. Top scoring candidates constantly ask themselves how to identify limitations, hidden assumptions, and alternative interpretations. When you're looking at a super complex circle geometry problem, are you just blindly plugging in numbers? Are you actually evaluating the evidence? Are you noticing that a specific line must be a tangent because of some hidden assumption in the diagram? That precise level of evaluative thinking is exactly what Cambridge rewards with the highest possible marks. Check out this breakdown. There is a massive difference between a basic descriptive approach and the evaluative thinking that Cambridge actually demands. A basic approach, well, that just writes down the formula. An advanced approach takes it a step further and applies the formula logically with clear working. But the top-tier evaluative approach, that student is actively justifying their decisions with evidence, comparing different mathematical approaches, and recognizing exactly why a certain step is necessary in a multi-stage problem. It's a total game changer. So I want you to ask yourself this exact question as you apply today's blueprint to your next past paper. If method marks are genuinely awarded for the process, what hidden assumptions are currently derailing your analytical reasoning? Don't just rush to get to the finish line. Prove your logical journey every single step of the way. Thank you so much for joining me in this explainer. Now go put this entire framework to the test.